Next, exercises related to composition of functions. So here two functions are given to us, f and g. For them we need to find these things. F of g of 0. First of all, g of 0 is minus 3. And f of minus 3 is minus 3 plus 5, so that is 2. B. G of f of 0. F of 0 is 5. And g of 5 is 25 square minus 3, that means 25 minus 3, it is 22. C. F of g of x. G of x is x square minus 3. And f of that is x square minus 3 plus 5, because now in place of x we have x square minus 3, so we have to add 5 to that. That means x square plus 2. Then D, g of f of x. F of x is x plus 5, and this is x square minus 3, so that means x plus 5 whole square minus 3. If you want, you can expand this. It will be x square plus 2 times x times 5, that means 10x plus 25 minus 3, that is 22. Then E, f of minus 5. F of minus 5 is 0. So that is this 0 is the inner f of minus 5, and f of 0 is 5. So f of minus 5 is 5. Then f g of 2. First of all, if we put 2 here, we have 4 minus 3, which is 1. So that means this is g of 1. And now again, in the formula for g, if we put x equal to 1, we get 1 minus 3, that is minus 2. Then g is f of x. F of x, first of all, is x plus 5. And then again we add another 5, so that means x plus 10. Note one thing, that it's not necessary to always apply the formula to the inner function first. That's not necessary. You can carry out the computation like this also, because f of x is x plus 5, so f of x is f of x plus 5, and then you can use this formula. That way also you will get the same answer. And finally, g of x is g of x square minus 3. G of that is this minus 3, and this will be what? X square minus 6x plus 9 minus 3, that means plus 6. Then 44 is something similar. If f of x is x minus 1 and g of x is the reciprocal of x plus 1, find the following. Okay, here also we have parts. Part A, f of g of 1 divided by 2. Part B, g of f of 1 divided by 2. Can we fit part C here? Yes, f of g of x. Then D, g of f of x. E, f of 2. F, g of 2. G, f of x, and finally H, g of x. Solution: A, f of g of 1 over 2. Okay, g of 1 over 2 will be what? 1 over 1, it will be like this. That means 1 over 1 divided by 3 by 2, which is 2 by 3. If you want, you can show the details here also. Or if you also want, you can calculate it in 2 steps. First you calculate g of 1 by 2, and then f of that you calculate separately afterwards. Okay, then f of 2 divided by 3, and this will be minus 1 over 3. B g of f of 1 over 2 f of 1 over 2 is 1 over 2 minus 1, that means minus 1 over 2, and this will be plus, this will be 1 divided by 1 divided by 2, that means 2. C f of g of x g of x is 1 over x plus 1, and f is that thing minus 1. So this will be 1 minus of 1 plus x divided by x plus 1, that is minus x divided by x plus 1. D g of f of x x minus 1 x minus 1 plus 1, so that is 1 over x. Then f of 2, f of 2 is 1 because we are subtracting 1 from the input, and because of that again f of 1 is 0. F g of 2 we add 1 to the input and take the reciprocal of that. This will be what? 3 plus 1, 4. That means 4 divided by 3 in the denominator. So 3 divided by 4. F g f of x f of x is x minus 1, and f of that is x minus 1 minus 1, that is x minus 2. And g of x one over x plus 1, so they have kept the most confusing for the last. x plus 1 plus 1, that means x plus this is 2. In calculating these compositions, their expressions are some particular value. We are not really concerned about what x should be. For example, here you can see that x cannot be minus 2. Okay, we are not concerned about the domains of these composite functions. That is a different matter altogether. So don't if you are thinking how one can have x plus 1 in the denominator, or for example here x plus 2 in the denominator, when one does not know what x actually is, you just take the point of view that these are some given formulas. Then after finding this expression, if one wants to find the natural domain of this function, then x will be restricted. Then we will say that okay, x must come from here. As far as just calculating these expressions go, we don't have to bother about what x is or from where it's coming. Okay, so that is 44. Then 45. If u of x is 4x minus 5, phi of x is x square, and f of x is 1 over x. Find formulas for the following. Again, there are parts. So this time we are going to calculate compositions of these three functions in several different ways. The first one is u of v of f of x. Part B, u f v. C, phi u f. Then D, v f u. E, f u v. And f v u. Oh, so that means there are three functions and three of them are involved in each one of these compositions. So there are 6 possible compositions like that, because 3 factorial is 6. These are all the number of ways you can permute u, v and f. Okay, so let us calculate. This one naturally will be a little bigger than the previous calculations, each one, because there are 3 in each. First of all, we again, like before, we come outside from inside. U of v of f of x is 1 over x. Okay, v of x is, okay, so v is squaring. So this will be 1 over x square. And u is what? 4x minus 5. So that means it will be 4 divided by x square minus 5. We can just keep it like this. Then b is u of v. Okay, v is squaring and f is taking reciprocal. Oh, so we are going to get the same thing, okay? That is 4 divided by x square minus 5. Then C, VUF. Okay, u of 1 over x is 4 divided by x minus 5, and v of that is square minus 5 whole square. If we want, we can expand. 16 divided by x square minus 40 divided by, will it be 40? Yes. Plus 25. Then D, VFU. Okay, U is 4x minus 5. And F is taking its reciprocal, that is 1 over 4x minus 5, and V is taking square. Sixteen x square minus 40x plus 25. E, FUV. 4x square minus 5, and f of that means it's reciprocal. And finally FVU. U is 4x minus 5. V is taking its square. And F is taking its reciprocal, which is again this one. Okay, let me just see for once whether what I have done is correct or not. VFU, FVU, but still we are getting the same thing, and there is actually a reason for that. 16x square minus 40x plus 25. The reason is this. These two things are equal. F of V of x and P of f of x. P of x is what? X square, and f of that is 1 over x square, whereas f of x is 1 over x and v of that is its square. That means ultimately it's again 1 over x square. It's because of this that whether we have which one? This one, Vf or Fv, it does not matter, you are going to get the same thing. So the solution ends here. Then 46. Another one, a similar one. If f of x is square root of x, g of x is x divided by 4, and h of x is 4x minus 8. Find formulas for the following. A. HGF. B. HFG. C. GHF. should be GFH. Yes. What else has not come outside? HG, that means F will now come outside. FGH. And finally FHG. The last one is FHG, yes. Okay, this time f is the square root function, f of g of square root of x, and g is what we just divide by 4. Whereas h is 4 times the input minus 8. So that in this case will be root x minus 8, because 4 and 4 they will 1 over 4 they cancel each other. B, h of f of g of x x divided by 4 h of, so this time we have to take the square root of this, x divided by 4. Now square root of x divided by 4 is square root of x divided by 2. So in trying to decide what these things will be, you assume that x is what it is supposed to be, that is x is a non-negative real number, although nothing has been said. But when one will, if one actually wishes to calculate the natural domain of this function, this composition of 3 functions, then you can see that one will have to assume x to be a non-negative real number. So you assume that that is the case, so you can calculate pretty much how you would normally calculate. So 4 times this minus 8 is 2 root x minus 8. Then C, GHF, GH square root of x. Okay, h of square root of x, so that means g is there outside, h is this 4 root x minus 8, and g, for g we will divide by 4, so that means this d, GFH for x minus 8 for x minus 8. Here the set from which x can be chosen obviously is no longer the set of non-negative integers, but it will be the set of non-negative real numbers. So in this case it will have to be the set of all real numbers greater than or equal to 2 to make the expression 4x minus 8 non-negative. Okay, so now g of this is what? We again divide by 4. Now if you take 4 common out, that means because of the square root 2 will come out and you will have 1 over 2 times x minus 2. So from here you can see much more clearly that x has to be greater than or equal to 2. But then again we are not concerned about that. Here we just want to find the formulas. F G H for x minus 8. So in the previous one also h was there inside, so we had 4x minus 8, but then we had gf, now we have fg. So g will be applied first. G means division by 4, so this will be x minus 2 and f is taking square root. So we don't have the 1 over 2 here. And finally FHG. Four times this minus 8, that means x minus 8, and f of that is square root of x minus 8. So in this case x has to be greater than or equal to 8. So that completes the solution. Let f of x be equal to x minus 3, g of x be square root of x, h of x be x cube, and j of x be 2x. This time we are not going to calculate compositions for these functions, but rather it will go in the opposite direction. We will be given some function, we will be asked to say what that function is in terms of composition of these functions in some order. Express each . of the functions in exercises 47 and 48. As a composite involving one or more. One or more of these functions f, g, h and j. Okay, so let us see those functions. A, y equal to square root of x minus 3. B, y equal to 2 times square root of x. C, y is equal to x to the power 1 over 4. D, y equal to 4x. E, y equal to square root of x minus 3 whole square. F, y equal to 2x minus 6 whole cube. Okay. So let us first see for once what the given functions are. F is subtracting 3. G is square root. H is cube and J is multiplying by 2. So here we have square root of x minus 3. Minus 3 means f. But f of what? F of square root of x. That means this is f of g of x. First, when you calculate g of x, you get f of square root of x, and f of square root of x is root x minus 3. Then b, y equal to 2 root x. Will it be nice if we do it in steps, say, for example, like this? Instead of just simply writing the final answer, let's write like this: f of g of x, 2 root x. 2 means j. J root x, so this is j of g of x. C is this, you can clearly see, is the square root of the square root of x, which is of course g of x. Then d y is equal to 4x. 4x means 2 times 2x, so j of x, multiplying by 2 times, then e square root of x minus 3 whole square. Outside we have the outermost thing is square root, so outside we will have g of x minus 3 whole square. Okay, now we think of the inner one, square of something. Square means, okay, we don't have square, no? Is it really square or cube? It is given to be square. Okay, because we don't have square, so what can we do? We have to keep the square as square. So we can at most write this. But f of x is x minus 3. So g of f of x whole square. That's the best we can do. Then if we want, we can define, we can name the square function by something and then use that here, but that is not given. And then finally f. Y equal to 2x minus 6 whole cube. Since we have cube, so that means h will be the outermost function, h of 2x minus 6. Now you can see that this is h of 2 times x minus 3. 2 times means j of x minus 3, and x minus 3 is f, so h of j of f of x. I am a little suspicious about this one. It may be the case that I have taken it down incorrectly. If you spot any mistake, if you look in the actual text and you spot a mistake, maybe we have a 3 here. I don't know, and I don't have it right now with me. So you can then let me know if that happens. Okay, so this is 47. Then there is another one, similar one, 48. Here a is y equal to 2x minus 3, b y is equal to x to the power 3 by 2, 3 over 2. Then C, y equal to x to the power 9, D, y equal to x minus 6, E, y equal to 2 times square root of x minus 3, F, y equal to square root of x cube minus 3. Okay, so let us start. A, 2x minus 3, 2x means jx, jx minus 3, and minus 3 means f. So this time around we have written the innermost one like this first. It may create confusion with that one. So because this is minus 3, this is f of 2x, and then 2x is j, so jx. We could have obtained this same thing had we proceeded in that way, but since we are taking care of the outermost function first, so let's just maintain that. B, now this is the cube of the square root of x. Cube means h, and square root is g, so h of g of x. C, C is 9. This is the cube of the cube of x, which you can clearly see is h applied to on x 2 times, so h of x. Okay, now we need this, or in fact let's just continue from there. No need to wrap this part off. Then D is x minus 6, which is x minus 3 minus 3. So this is applying f twice, f of x. E, 2 times square root of x minus 3, 2 times means j, square root of x minus 3, square root is g, and x minus 3 is f, so j of g of f of x. Then f, y equal to square root of x cube minus 3. Square root is the outermost one, so g of x cube minus 3. Minus 3 means f. G of f of x cube, and cube is h, so g of f of h of x. These exercises of trying to recognize what the given function is in terms of compositions will be helpful later on when we learn how to differentiate a given function which turns out to be a composition of some other functions which are easier to differentiate. If you are able to for example, recognize the given function as a composition of some functions which are much more simpler than the given function, which can be readily differentiated, then you can use this sort of formula and the chain rule to calculate the derivative. We will see these things when the time comes. Then exercise 49. Copy and complete the following table. A table of some functions is given. We will now take the table down. Okay. I hope I won't run out of space. I need 7 rows. Okay, the table looks like this. Here in this column we have the function gx. Here we have f of x, and here we have the composition of f and g. These are names that label the functions. And these are some entries given in the table. X minus 7 square root of x, x plus 2 3x, square root of x minus 5, square root of x square minus 5, then x divided by x minus 1, x divided by x minus 1, and this one is empty. 1 plus 1 over x, x, 1 over x and x. Okay, we now have to figure out the empty spaces. Of course, we are not again going to draw the table, but here itself we will complete the table by writing the appropriate entries that are not there. The first two are very easy, we just have to directly calculate the compositions. First we apply G, and then on that we apply F. So that means F of x minus 7, and F is square root. So this will be square root of x minus 7. Then just like that here, first we have x plus 2. We have to take 3 times of that. So that means 3 times x plus 2. Or if one wants, one can simplify this also. One can write 3x plus 6. Note that g is appearing first, and after that f is appearing, because here in calculating this composition we are applying g first to x, that's why. Okay, this one seems a little tricky, but we can figure this out also, not just simply by assuming something randomly, but actually what you do, you don't know what g is, okay, however you know f composition g of x is this, square root of x square minus 5. Now what is f composition g? F of g of x. Now you don't know g, but you know f. So f of x is square root of x minus 5. So f of g of x will be square root of gx minus 5. So from this you can now easily guess that g is the square function. So this is x square. Then what about this one? Here again, just like the first two, f and g are both given. So we can directly apply the formula, but be careful, f and g both have the same formula. So f of this, that is x divided by x minus 1. Now g is also that, so in place of the variable we have to put this expression. That means this, and if we simplify, what do we get? minus 1, x minus x, they will give us 0, minus of minus 1 is plus 1. So after simplification, these two things get cancelled and we have x. So that means we have x here. Then again, like that other calculation, here we need to guess g. Just like before, this time f of g of x is equal to x. F is given this one, 1 plus 1 over x. So 1 plus 1 over gx is equal to x. That means 1 over gx is x minus 1. So gx should be 1 over x minus 1. Now if just for the sake of seeing or checking whether we have found the correct one, you put the, what I am trying to say is this. Here you put this expression for g, that is in the formula for f, you put the expression for g, that is actually calculate this left hand side for this expression. This will be what? 1 plus x minus 1. Yes, you are getting x. So g will be 1 over x minus 1. And now in this last one we have to find f. Still we have f of g of x, but now g is known but f is unknown, and the final answer is x. F is unknown but g is known. G is given to be 1 over x. If you want to make, if you want to turn 1 over x into x, what do? You again take reciprocal. So although f is not given, but it's easy to guess. So these are the missing entries in this table and we have completed it. Let us solve one more. It has a small name also. It's called a magic trick. You may have heard of a magic trick that goes like this. Take any number add 5, double the result, subtract 6, divide by 2, then again subtract 2. Now tell me your answer. And I'll tell you what you started with. Pick a number and try it. Okay, we will do, but what is the exercise? You can see what is going on if you let x be your original number and follow the steps. To make a formula f of x for the number you end up with. Okay, before we do that, let us do this thing. Let us take not just a single number, but actually maybe two numbers. Now by number, actually we can take any number, but usually to keep things simple, positive integers are taken. to keep the calculation somewhat manageable. So let us take the number, for example, 10, and now let us follow the steps that are given here. Take any number at 5, so that means we get 15. So that is the first step. Double the result. Subtract 6. Divide by 2. Subtract 2. Now tell me your answer and I will tell you what you started with. So we are getting the same number back. Let us try another one. This one was even. Let us take an odd number. Let's take a very small number, smallest one, 1. So we have to first of all do what? Add 5, 6, then double the result. Subtract 6. Divide by 2 and subtract 2. Yes, we are again getting the same thing back. If you take a negative number, say -5, what happens? Add 5, so that means 0. Double the result, again 0. Subtract 6, -6. Divide by 2, -3. And subtract 2, that means -3 minus 2 is -5. Yes, so we are getting what we started with. You can see what is going on if you let x be your original number and follow the steps to make a formula f of x for the number you end up with. Without writing in detail all the things, we pretty much understand what we are doing. So let us follow the steps given for a general number x, which is any real number actually. So we have to first add 5, then double the result, and let's simplify it also. 2x plus 10. Then after that subtract 6, so it will be 2x plus 4. Then divide by 2, x plus 2, and then subtract 2, so we get x back. So it works for any real number, but the question is, suddenly why is this exercise here? That is because it is a composition of functions. We have a composition of many functions. One of them is, you can in fact look at the steps. Each step is actually a function. You can think of the functions like this. Say f1 of x is x plus 5. Add 5. Double the result. f2 of x is 2x. f3 of x, subtract 6, x minus 6. f4 of x is divided by 2. Then f5 of x is subtract 2. And this sequence of steps that we see here can be expressed. This fact that we start from x and get x back after performing these steps in this order can be expressed by this equation. f5, f4, f3, f2, f1, x is equal to x. It is because of this that we get the same thing back. If you want, you can write it in a systematic manner as an actual solution. So let's end the video here itself. It's somewhat short, but there is no need to always go through extremely long videos. We can take our time with these things. No need to rush through this unless you are, of course, preparing for an examination. Tomorrow again we have real analysis. So we are going to start section 6.4, right, where we will see limit points of sequences, upper limits, lower limits of sequences, those things. So we will see that tomorrow. Until then, this is me, Lucifer, from A Mathematical Room. Have a nice night.